4, we're going to get the same limit again, but now we're actually going to prove that the limit really is 4 using algebra. That is the only way you can prove that the limit is 4. I think it's still in the clipboard. Yes, there we go. So again, the same exact limit. All right. So let's start it out. So how we do this by algebra. So we've actually already kind of done some of this, right? We've already done the algebra essentially. But we're going to now talk about this in a slightly different context. Okay, so I start with my limit. So let's kind of, again, kind of review what the story is here. I want to know what is happening to the values of this expression as x gets closer to 3. Now, usually if I plug in the number x equals 3, that gives me a very good idea of what's happening. But the issue is here, you can't plug in x equals 3. You get division by 0. And in fact, all of the interesting limits that we do in this class have that property where you plug in the number and you get some nonsense expression. So we have to come up with a different way. Okay, so what we're going to do is we're going to say the following. Okay, well, I can factor the top as x minus 3, x plus 1. Right, that's just algebra, right? That's just factoring. That's always true. But now I want to be able to cancel out the x minus 3. And why am I able to cancel out x minus 3? So already says because it's in the numerator and denominator. Actually, not quite. And Jordan says the same thing. Your x minus 3 is in the top and bottom. So I know what you're saying that because that's kind of the algebraic rule you remember, right? If you have a common factor in the numerator and denominator, you can cancel it out. But here's a question. Is x minus 3 over x minus 3, is that equal to 1? This almost seems like a trick question. Why is Dr. G asking this? And you probably now think the answer is no because of the reason I'm asking it. So Aya says, yes, it is. Should we do a quick poll just to make sure actually? So the poll will be kind of like a quick yes or no, and it'll also be kind of a, just to make sure people are kind of awake and alive, right? Is that good? Sometimes, maybe. Like if you catch them like at a good day, like, right? Is x minus 3 over x minus 3 equal to 1? And so here we go. So the choices will be, let's see, yes, no, sometimes, I don't know. I think that probably covers, all the possible answers you could have, right? So let's see, poll number 2. So let's see. So what does the class think in general here? We're almost at a hundo. Come on, we just need a couple more people. 14 more people, 13 more people. 8. Are you all here? Are you all alive and awake? This is the test. And if you fail, that means you don't get credit for like anything this week. Like even if you give in your recitation activity, that's it. You know, it's really funny is, a colleague in his syllabus, he put a little statement in the syllabus. He was very clever. He hid something in the syllabus that says, no matter what you do this week, all you have to do is write that my favorite Pokemon is Kabutops on the first activity or something like that, but don't actually do the activity. This is just a test to see if you read the syllabus. And First of all, I had to tell him like Kabutops, really? Like that's really your favorite Pokemon. But second of all, I just thought it was kind of fun. And 3 people did not fill out the poll. Sad days. Expose. I don't know. I don't. If I had to guess my favorite Pokemon, I don't know what I would say, but Kabutops would definitely not be there. Okay, so as usual, remember the highlighted answer means the most common answer, and 65% of you are wrong. The answer is, I would say the answer is because I had the sometimes. I guess sometimes would be the answer. Although no is also acceptable because equality. There could be an assumption: is this true for all X? And the answer is no. So Magikarp is the best. All right, so the answer, I guess, is sometimes. So why is it sometimes? And I think I already saw a few people actually say what I was trying to get at. The reason this is not always equal to 1 in general is because it's not true for all X, right? X minus 3 over X minus 3 is not equal to 1 if X is equal to 3. Well, we can discuss Pokemon after the class. So note, X minus 3 over X minus 3 does not equal 1 in general. Right? What if X equals 3? Now, it seems like I'm being very pedantic here, and I am, but for a good reason, because this really goes to the heart of what a limit really is. The reason I'm allowed to cancel at X minus 3 is because what does X approaching 3 mean? X approaching 3 means X is, I'm allowed to consider values of X that are near 3, but not equal to 3, right? So this limit symbol, lim as X goes to 3, that is actually telling you, hey, actually X is not equal to 3. X is just near 3, but X is not equal to 3. So do with that assumption what you want. And so what we're going to do is, okay, you told me X is not equal to 3. I'm going to say, okay, now I can cancel them out because if X is not equal to 3, that cancellation is perfectly okay. Okay. So I see a little bit in the chat. So Aya, can you you said how? Can you just clarify what exactly you were asking about? How in response to what? And I see a few people then saying the denominator would be 0 if X equals 3. Oh, I guess you're asking about why is this circle statement correct, right? So if X is equal to 3, you get 0 over 0. That's undefined. Division by 0 is undefined. It is not a number. So in particular, it can't be equal to 1, right? If X is not equal to 3, then yes, you can cancel this out. Okay. So I really want you to kind of get that idea in your head, right? That when we do this cancellation of these factors, I'm allowed to do that only because I'm under the limit symbol. And the limit symbol allows me to assume, in this case, that X is not equal to 3. So any factor like X minus 3, you're allowed to cancel it out. Okay. And then we can just plug in X equals 3. Now, that's a little bit of calculus. That's something I haven't actually shown you. Once you get down to an expression like X plus 1, you're allowed to just plug in X equals 3. But only certain functions have that property. Polynomials are one of those functions, so that'll be for next lecture. So this last step I haven't really justified to you quite yet. You just kind of have to believe me that you are now allowed to just plug in X equals 3. Let me actually say plug in X equals 3. There we go. Okay. Simran says, I think I'm confusing 2 different values. What is the difference between an undefined value such as 5 over 0 versus 0 over 0? So good question. Actually, we'll talk more about that next lecture when we do limits. So both of these are undefined. 5 over 0 and 0 over 0 are both undefined. But 0 over 0 is special because 0 over 0 is actually what's called an indeterminate form. When you encounter it in limits, what it really means is you don't have enough information yet to determine the limit, and there's more you have to do with it. 0 over 0 kind of tells you there's algebra to cancel out or something else. I mean, they're both undefined. Just 0 over 0 kind of hints at you how to do how to do the limit. It's a special kind of form. But they are both undefined. Division by 0